Hi. Previously, we have studied chlorination under the halogenation reaction. One reaction was left over, one topic was left over under the category of halogenation, and that is iodination. So, iodination is pretty easy to do. There is not an issue about it. Everything is pretty fine. So, benzene would be treated with iodine to give iodobenzene, and the reaction would be called iodination. And there is no need of any Lewis acid catalyst. Lewis acid catalyst was required while doing chlorination and bromination, but with iodination we do not require Lewis acid catalyst. But there is another challenge in this case, and the challenge is the product iodobenzene can revert back to the reactant because the reaction is reversible reaction. So the product formation is happening, and after some time the product will revert back to reactant. So it's a challenge. How do you keep the product as it is? This thing is also being displayed by the equilibrium arrow, which is being shown that the product can revert back to the reactant. Now to stop this thing, we are using an oxidizing agent called iodic acid. Now let us first understand why the product was reverting back to the reactant was the side product, which was hydroiodic acid. It can reduce the iode of benzene to benzene. Reduction means you remove anything and you add hydrogen, because addition of hydrogen is known as reduction. So hydroiodic acid was a very good reducing agent. So it could reduce iodobenzene back to benzene. So that was the reason of reversibility of this reaction. In order to solve this problem out, we are going to use one oxidizing agent, which is iodic acid. So it will react with the side product, which was hydroiodic acid, and it is going to convert this hydroiodic acid into molecular iodine. So your one of the reagent is getting regenerated. So this way, this challenge of hydroiodic acid converting iodobenzene back to benzene can be solved if you use iodic acid alongside your reaction. So this is what is written over here. Now moving to the mechanism of the reaction, we have to cover the mechanism as well. The first step is going to be generation of electrophile. So no Lewis acid catalyst is required. Even the molecule of iodine itself will break up, and the bond breakage would be in a fashion when both of the electrons would be transferred to one iodine atom, and the other iodine atom would be left over with no electrons. So it will lead to formation of I positive ion and the I negative ion. This I positive ion would be called iodinium ion, and it is going to be the electrophile of our reaction. So in the second step, benzene will attack over the iodinium ion, and it is going to be a slow step, and you can show that this carbocation is stabilized by resonance structures. In the third step, this iodine nucleophile, which was generated over here, it will take this hydrogen as a proton, and the two electrons of this carbon hydrogen bond will be shifted back to the benzene ring that will regenerate its aromaticity. So this step is going to be a fast step, and the final product will be formed is iodobenzene. Now other thing would be formed was hydroiodic acid, and taken care of by the iodic acid, because it will convert the Hi to molecular iodine as a reagent. So reversibility of the reaction could be dealt with. So that's it with iodination. That some points are there with the reactivity of halogenation. So while you are doing chlorination and bromination, you require Lewis acid catalyst like ferric chloride or aluminum chloride if you are doing chlorination, or ferric bromide or aluminum tribromide if you are doing bromination. But that is not required when iodination is being done. With iodination, you do not require any Lewis acid catalyst. But the challenge with iodination reaction is it is a reversible reaction. So this can be dealt by the use of iodic acid as an oxidizing agent. So this can reduce the hydroiodic acid to iodine. So this problem can also be fixed. So this way you can perform halogenation reaction on benzene. So that's it with halogenation. In the next session, we are going to start a new topic with that name, Friedel-Crafts alkylation.